then the cold air meets the jet stream. And the jet stream is what designs the wave, or gives this front its formation. See, this whole thing's coming down like this. Right in here we have a situation. We'll talk about that in lesson 3, or whatever, 2. And then right here is another part of this wave. See, the wave actually goes like this. Comes up, goes over, and goes down, and goes behind me over there. See how it comes up a little bit right in there? Right there? See? So that's the wave coming back up the other side. Awesome, isn't it? Now, you see how you can help predict the weather with this? How it can be helpful? Think of it as a wave. Now let's say the wave is up here in the state of Washington. Well, if the Earth is going that way, which way is the wave going to go? It's going to go this way. And see how this is dragging down here? So this wave will stay like this and come right across the United States. So all you have to do is look at different things that you need to look at in the weather maps, on the newspaper, or the TV channels, whatever. What you're going to do is watch this move. And after you see how long it takes for it to go from like California to the East Coast, figure it out. 5 days, 7 days, and then notice when the next wave comes through. And see how long the wave takes. All you need is 2 waves. And then you're going to know how long is the time of period from California to the East Coast. It may take 5 days, it may take 7 days. Take, for example, if this is 5, then this would be 4, 3, 2, and right here in this part of the world, in the United States, would be 1. It's here. So you would be able to predict it. Let's say today is Monday morning, and this wave is here. That could be like 2 to 3 days away. You'd have to check that out. But see, this would be Monday, Tuesday, Wednesday, Thursday, rain in this part of the country, or up here, the rain. So you just watch that. And that's how simple that is. And you say, if it's that simple, how come the weathermen don't do it? But they do now. Ever since these satellite photographs have been available, weather predicting is becoming very, very accurate. It has really improved. So you can see how this can be helpful to that. But now there are other things that can happen. I mean, the weather has only been predicted twice correctly. That's when God told Noah it's going to rain. And then when the prophet in the Old Testament talked about the fact it's not going to rain for 5 years unless you get your act together, you know. So 2 times in the Bible that's actually been mentioned. But weathermen do their best. And here's another thing. Weathermen will not really, they'll say a possibility of. They can't say it will definitely. Because we had a situation in one part of the United States where it got so cold, the crops froze, and the Weather Bureau did not give a frost warning, and the farmers were able to sue the government because they failed to notify the farmers. Now, the money they got, of course, was to plant the new crops and dig up the old and be all set. So it was quite a bit of millions of dollars, but the point is, you can sue the government. If you're wrong and you're predicting by the end of these 4 lessons, you know, you're only a kid, right? So, but you can learn it. It's really neat. You'll really be able to practice this. Okay, that's enough of that. So let's go over now and let's take a look at the whole Earth itself and see what we can find out about this wave and this jet stream. Well, what do we got? Come over here to the table, and do you realize how big a hole that would be in a newspaper? This is what I was telling you about. This is where you get your maps, the weather maps. And remember, I reminded you, if not, I'll tell you right now, I want you to get 1 entire week. You know, Sunday, Monday, Tuesday, whatever it is. Get yourself 7 days. And then as you look at these weather maps, you will be able to see from each day to the following day to the following day how these lines change on the map. And that is how you can actually use these as a reference. Okay, now that's one way you can get a source. Of course, the other way would be go to your internet, and this can be used because this is from NOAA and sometimes NASA. You can't just take something off certain channels and your local news. There's copyrights and all that. Have you ever noticed that? So anyway, you can get it through the newspaper or check your internet system, or of course look at your local TV station, and that will also give you the maps that you can follow. And the map that you see with the clouds on it is really important for checking your jet stream. Remember we talked about the jet stream, all right? And these maps from the newspaper, those are great to see where your fronts are. And the front doesn't always indicate where the jet stream is, but it's pretty close. All right, we have a globe sitting here. Boy, I tell you, I've been looking for years for a globe like this, and I finally found one because it's got magnets on it. But you know, I was talking about internet. I almost forgot. It's time for a commercial. Oh yeah. You see, if you have any questions, keep them to yourself. No. You can contact me through my email address. Of course, it's American Online, isn't everybody almost? Us home consumers anyway. So you can send me a question, and I check my email along about 10:30, 11 o'clock every night. And that's about all I use my computer for that. So I'll be happy to give you an answer back if you have any questions in science. Be most happy to handle on that. As you may or may not know, I teach homeschoolers, and I usually run about 150 kids a year. And a lot of those students are send their email to me and they have questions or just say hi. But I'd like to hear from you, and it's available to you on ewimmers@AmericanOnline.com. Those of you know about that kind of stuff. I also have a website, but it's always under construction, and it's a matter of time to sit down and work with it. But the website would be Members. American Online, it's always Members, and then my name. All right, now let's get back to this globe here that I was looking for. It's magnetic, so I can put this H on here, and the H sticks. All right, first of all, let me turn the world around to where we get the Pacific Ocean, because it's nice and black. By the way, this globe came with all the water on it, but I picked it all off. This is like a puzzle. All right. You ready for this? George, the cameraman. It's straight up and down. Aren't you going to tilt it at 23.5 degrees? He didn't say 23.5. Probably didn't know that. But anyway, it's up and down. Do you know how important that is for weather? Who cares, right? Oh, no. Because the Earth tilts, it causes various changes in the weather and things to happen. And also because the Earth turns, also gives us weather changes. If you get my videotape on astronomy, and I'll give you a little clue now, the Earth is going to stop turning in the future. Boy, is that going to play havoc with the weather. And actually what it's going to do is kind of calm things down and make things more predictable. For example, hot air leaves the equator and goes up above the Earth. Now when the hot air goes up above the Earth, it chills out. You know, it cools off up here. So it has to come down. You know, that's the law of physics. Whatever goes up has to come down. Even if you're an astronaut, you're going to come back. So when the cold air comes down, being cold, it's got to come down where it's already cold in the Earth. Let's keep this simple. Where are the two most coldest places in the world? Not your refrigerator. Come on. The North Pole and the South Pole. So down comes the cold air. Up goes the warm air. All right, so here comes the cold air down. The cold air comes down, hits the Earth. Guess what it does? It gets warmer. So when it gets warmer, it goes further south, hits the equator, and goes back up again. So we have a complete, you heard this word, cycle, you know, up and down and across the Earth, up and down. Now, that's how it works if the Earth did not turn. But since the Earth turns, as the air comes down, the turning Earth causes it to turn. It causes the turn. So if the Earth did not rotate, it'd be straight down and right back up, straight down, right back up. But now since the Earth rotates, it has the curve. Now we got the other thing. Remember the cameraman George, he's upset, remember? Okay, we got to tilt this thing at, what, 23.5 degrees? I'm just guessing, you know. Good scientific guess. Scientific guess, sometimes, if you're professional enough, we call it a theory. All right, so we have then this tilt. Now, what does the tilt do? It gives us the seasons, dude. Summer, fall, winter, and spring. If we did not have the tilt of the Earth, if we were straight